everyone, I'm back with another Figure It Out episode. Last week I shared all of the first things I did when I first purchased my charger, so what physics problem could I possibly do that is related to that day? Well, if you remember, I mentioned it was a scorching 107-degree day, and whenever anyone talks about Las Vegas heat, someone always says, yeah, but it's a dry heat. But was it really truly a dry heat that day? Well, not exactly. Unless the humidity is at 0%, we will never truly have a dry heat. In fact, according to an almanac, the relative humidity on the day and time I left the dealership was about 8%. So, as I prepared for today's video, I thought 8% is low, but that still means there is some type of moisture in the air. How much moisture was actually in the interior volume of my car at the time I took delivery of my car while it was sitting outside? So today's Figure It Out question is, the temperature in the interior cabin of a Dodge Charger is 107 degrees Fahrenheit or 42 degrees Celsius. How many grams of water are in the interior cabin if the relative humidity is 8%? Now, there are a few things we need to find out first. First, I know that the volume of the interior cabin area of a Charger is about 105 cubic feet. And converting to metric, that's about 2.97 cubic meters. Now, the equation for relative humidity is the actual vapor density divided by the saturation vapor density. All of that times 100, of course, because it's percent. I'm sure you remember that density is mass divided by volume. So the actual vapor density for our question today is the density of the water vapor inside my car. The saturation vapor density, aka SVD, is the total possible vapor density at a particular temperature, and it can be found in a table in your physics book. The density changes based on the temperature, so you'll need to find the value for the temperature in question. According to the table, the saturation vapor density at 107 degrees Fahrenheit or 42 degrees Celsius is 0.056 kilograms per cubic meter. We can now add that value to our list of given variables. So now we have everything we need to start to plug and play. Now remember, we always need to solve for what we're looking for, so let's solve the equation for the mass of the water vapor in the interior. Now, including all of our known variables, we can calculate the volume is at 2.97 cubic meters times the relative humidity, which is 8 divided by 100 times the SVD, which we found in a table to be 0.056 kilograms per cubic meter. That leaves us with 0.013 kilograms of water, or in other words, 13 whopping grams of water vapor were in the interior of my car when I took delivery of it outside the dealership. So comparatively speaking, that's the mass of about 2 nickels and a penny. Not much at all. So I guess I will stop giving people a hard time about saying it's a dry heat. So that's it for today, friends. Summer is here, and that means either you or someone you know will be starting the fall semester in a few months. Why not brush up on some foundational physics with me this summer? I know, you just want to have fun. I can't blame you. I will see you in my next video.